Hello, my name is Wan Muhammad Amirul Farhan, and I'm going to explain about the problem scenario. First, farming industry these days has several problems. Some of them, which we have identified, are related to our project. Tool use these days are currently not fully optimized, costly for most of our smallholder farmers, not convenient enough for them, especially for the elders. There are some problem arises regarding our agriculture field, especially for farming routines such as seedling, planter, and weeding. The tools used these days are currently not fully optimized and convenient enough for farmers. There are some problem arises regarding our agricultural field, especially for seedling, planter, and weeding. The conventional seedling tool used these days has some limitation, such as poor control over the depth of seed placement. Next is the objectives. We have several objectives to be achieved by the end of this project. The objectives are, first, to design and fabricate a multifunctional planting tool to help in farming routine for farmer, to make planting more accessible and imply ergonomic features on the product, and lastly, to test and validate the multifunctional planting tool, especially usability and cost incurred. Next is the scope. This project is based on the tool for transplanting plants that is already available in the market. But to increase the productivity as well as production in this agricultural field, we do make some improvement on the tool that may help in increasing productivity, production, and also reduce time for farming routine.
Assalamualaikum, my name is Azlan Abdullah and I will cover about the function and engineering analysis. First, we go to the assembly and motion simulation study. Motion simulations provide complete quantitative information about the kinematic, including position, velocity, and acceleration, and the dynamic, including joint reactions, inertial forces, and requirements of all the components of a moving mechanism. So we go to the seeder design assembly. So you look at here, we can see all the components in the design assembly. Next, we go to the seeder simulation. So we can see here they have pusher, they have the exit for the seeds. So also we go to the planter design assembly. So also this here is all the parts in the planter design assembly. Then we go to how the planter design works. So we have the connection and we have the feeders. With the design assembly and the simulation motion. So here we have the upper body and also we have the width remover, which is wheel remover will rotate their blade below. That's how it works. So next we go to the engineering analysis. We need engineering analysis because engineering analysis involves the application of scientific analytics, principles, and processes to review the properties and state of a system, device, or mechanism under study. Engineering analysis is decompositional. It proceeds by separating the engineering design into the mechanism of operating or failure, analyzing or estimating each component of the operation of failure mechanism in isolation, and combining the components according to basic physical principles and natural laws. So we go to the main body displacement analysis. So we can look here the handle is moved downward. Then we go to the feeder displacement analysis. So the feeder of the feeder displacement analysis is moved to the right. Then we go to the planter displacement analysis also. They have the bug in the upper body. So we have next we go to the feeder displacement analysis. So we have the handle displacement and optimization. So here we can see here design before optimization and design after optimization. So design after optimization is acceptable.
My name is Jufri Hanini bin Hassan. I will conduct about cost analysis. We have a fixed cost, variable cost, and overhead cost. Next, this is an assumption for calculation of product costing. You can see here. This is bill cost of the product. The total cost we get 247.38 cents. This is time required to machine to produce 200 units. We get 510 hours. Then we can calculate the total unit produced per day. We can produce 7 units only. This is a fixed cost. You can see here income tax, machine amortization, development cost, coolant cost. You can see here. This variable cost, our variable cost, you can see here also. This total product per month. we get 70,000. We get 70,760, 22 cents. Cost per unit. Also, you can see here profit margin and selling price. Also, you can see here. This is return on investment, ROI. We get 30%. So BEP we put in, we get 3 years. Okay, 3 years. So profit margin should be increased lah. Okay, when we get 3 years, then reduce the expected duration of BEP less than 3 years. Okay, this is a break-even analysis. We get 68 units. This is our table analysis. All right, and this is a break-even graph. Then this point we call it break-even point. Okay, thank you.
Number 1. To produce this multifunction planting device, we only use material which can be recycled and safe to human health and also environmental friendly. Therefore, we are designing multifunction planting that consider environmental factor by using a design eco-web tool that are most beneficial tool to designer in order to design a product that may help small and medium-sized enterprises SMEs to achieve sustainability through implementing eco-design approach. And here are the examples of study in eco-design tools used in SMEs. The second type of sustainability is social sustainability. Also can be poorly defined as socializing. Universal human rights and basic necessities are attainable by all people who have access to enough resources in order to keep their families and communities healthy and secure. All people are protected from discrimination. By using this device, all people are able to make agriculture available. All native also are able to use this device because of the lightweight proposed by this multi-function planting device. It is also contain a very simple steps to change the head from the seedling to weeding or loosen the soil. In the making of this device, also workers are secured by safety and manually steps are also provided when using a machine. And the third sustainability, which is the last sustainability, is economic sustainability. This is where most businesses feel they are on firm ground. To be sustainable, a business must be profitable. And we also design this device that are economical friendly. This is because our intention are to make agriculture possible to all and human communities across the globe to maintain their economic system. This multi-purpose planting device has long life that also can be repaired easily. The conclusion, there are some limitations and also recommendations such as the weight and the size of the product. But to overcome this limitation, the EduPack software is used to select a material that was low in density but the quality are still at the best. At the end of the semester, our group can conclude that our project on multi-purpose planting devices was achieved. Based on the objective, we can produce a product that will help many people, especially farmers, to increase their production and save more time on agriculture activities. So for our first objective, it was about the ability to us to generate and also produce a device that may function in some ways but still involve simple steps. As this device named multi-purpose is because we can change the head of these devices by using simple steps in order to loosen the soil, weeding, seedling, or other suitable activity as well. And besides that, we are dealing with a product that we believe have high ergonomic feature such as an adjustable length to give the farmer suitable height as their body measurement as an Asian. And finally, simulation and computer-aided design for each part were drawn and developed based on design requirements. Today, let's move on to our question and answer session Q&A based on our project, which
our friend asked us about there are any possibility to change the metal raw material with plastic-based material. And for this question, our answer was yes, we can change and use plastic material that was high in quality and durable in use. And we also can use other material which is suitable, and to make it sure we can use EduPack software, and it will help us to select the best material among the best. For question number 2 from Mr. Abu, it is possible to change or adjust the size of these multi-function planting devices according to Japanese and American? So basically, according to statistics, they are not really far different in measurement for an American and also a Japanese to a Malaysian. But to put it simple, we are producing a product that is ergonomics and it was measured and also produced according to normal distribution measurement of people. So actually, it might be suitable for them.